everyone hear me? Okay. My name's Joan Kersnar. I'm a drinking water planning manager at Seattle Public Utilities. And I'm here to talk about a project that we're calling PUMA, or Pilot Utility Modeling Applications. In a way, this talk is going to be like the fourth of the plenary sessions where Megan Dalton's going to speak after me on the same project. The project is a look at water utility climate change impacts, and it was a joint study with SPU and the Climate Impacts Research Consortium. The research consortium is made up of, if you don't know, is the University of Oregon, Oregon State University, University of Washington, and University of Idaho, and Megan Dalton's with Oregon State University. And so she's going to go into more detail on our project. I'm going to be talking a little bit higher level. I'm going to be giving you a little bit of background about Seattle Public Utilities and our climate program and what we hope to be getting out of the project and where we are with it at the moment. A little bit about SPU. Wolf had already kind of covered this. SPU itself is made up of 3 utilities. There's a solid waste utility that does garbage collection recycling, a drainage and wastewater utility that handles stormwater and wastewater within the city of Seattle, and then the water utility that provides water to 1.3 million people in the city of Seattle and in the communities surrounding Lake Washington. The sources of supply are primarily from the Tolton Cedar watersheds. They're in on the west slopes of the Cascades. The Cedar River watershed is immediately north of the basin with Howard Hansen that Kevin talked about. SPU operates those reservoirs not just for water supply for people, but also for fisheries, for in-stream flow resources. We also manage for floods, and we also produce hydropower at those plants, at those locations. Seattle, as most of you are aware, is involved in both mitigating and adapting for climate change. In terms of adaptation, our program is really focused around increasing our understanding of climate change impacts and our capacity to be able to deal with climate change impacts on our utilities. This particular project is going to be focused on some of these objectives. It's a little bit different than what we might have done in the past in that we are bringing more of the work, the assessment work in-house, and we're also involving more people, staff level people in the work so that we're actually building that institutional capacity. One partnership that we've been building on to address climate change is what we call WUCA, the Water Utility Climate Alliance, and that's an organization, voluntary organization made up of 10 large utilities across the US. The focus of the WUCA in terms of climate is really to come together and to be able to improve the usefulness of climate change science, and in particular to allow for better decision making given that we have uncertainties with climate change and its impacts. So the PUMA project falls out of the WUCA work in that partnership. It was a project that was designed to link up the Regional Integrated Science and Assessment Groups, the RISAs, with 5 of the WUCA members. And they are each looking at slightly different aspects of how climate change could impact their utilities. They're looking at water supply, they're looking at water quality impacts and stormwater impacts. And at the end of this project, WUCA is going to develop a white paper on lessons learned from each of the different projects going on how well these tools are working, and what did we learn from the various projects. So it's really a joint learning from across the US. In terms of this particular project in SPU and the relationship with CERC, we have a number of questions that we had that we're going to be exploring. One of them is on water supply. We've done 2 assessments already. This would be a 3rd one. And to go into a little detail on that, we're using an approach that we've done in the other 2 assessments where we're using this chain of models approach where we take the GCM data, downscale it, feed it to a hydrology model, feed it to our water systems model, and then use it in our utility planning. A little bit different in terms of where SPU and the researchers are involved in that chain of models. In 2002, Seattle was at the end of the chain. The researchers brought it all the way through the systems modeling, and then SPU use that information to decide how to incorporate into utility planning. In 2007, we moved up the chain a bit. Researchers were involved through the generating the hydrology. The hydrology was then handed off to the utility, and we ran it through our systems model to look at impacts on water supply. And then we incorporated that into our utility planning. In 2014, we're going up the chain again. In this case, we'll be receiving downscaled MET data, feeding it to our own in-house hydrology model that we use in day-to-day operations, feeding that into our systems model, and then utility planning. So this round of research that CERC is working on is making use of the new CMIP5 data, 20 GCMs, 2 of the concentration scenarios, downscaling that to create 40 data sets, 150 years of data. That's downscaled at the daily level and disaggregated to an hourly time step to feed into the process. Okay. Another aspect of supply that we're looking at is creating storylines. So we're looking at what I consider to be metrics that might be easier to explain impacts to the general public, duration of dry spells, number of dry spell impacts, and then translating that storyline into what does it mean to our water system. And we're also looking at forest fires. We want to know how forest fires might change over time for our watersheds. For example, the Cedar River watershed that Rolf described earlier is 90,000 acres of forested watersheds. That source is also not filtered. It provides 2/3 of the water supply. And if forest fires lead to higher turbidity events, we want to know that because there could be issues and implications into treating that water for water supply. We're also looking at timing of fall rains. As Kevin described, our watersheds is very similar to Howard Hansen in that the storage capability is used within a single year. It's not like other large, like Colorado River Basin water supplies, where there's multi-year storage. The volume that's available in those reservoirs is small relative to the inflows. So we refill every year and draw down. So during that drawdown period, during the high usage by people, the reservoirs, and that's a time when inflows are low, so the reservoirs being drawn down. How long that reservoir storage is needed depends on when we start recovering and when we recover because of the return of the fall rains. So we're looking at that. And Megan's going to go into a lot of details on the preliminary analysis we have on that, that work for this study. We're also interested in atmospheric rivers and flooding, ENSO-PDO cycles, and how those may change over time. We're also looking at other sectors. The work that's being done here can also be translated and used for the drainage utility. For example, a threshold precipitation level that has implications to the city's drainage system. Okay, and this is sort of like a point where it's linked to this morning's session, really just talking about the benefits of co-production. As was mentioned this morning, it's important for this to work well, to have early conversations so that we understand, so that researchers and the utilities understand the needs of each of the parties, design the work, who's going to do what products are going to be produced. And there are benefits that have been mentioned earlier. For the researcher, it's an opportunity to educate the resource managers on the impacts of climate change. It also allows them to understand better what's going on behind resource management and more likely to produce useful products. For the utility, it's really making use of what we already have in terms of a good understanding of our system. And also, it builds on that understanding of how climate change is going to impact that. As one of the WICA members says, if you don't understand how your hydrology works now, you're not going to understand how climate change is going to impact the hydrology. It also leverages the expertise of the climate researchers and for not just generation and interpretation. There's a lot of information, a lot of data that needs to be manipulated and transferred from GCMs all the way down to utility planning. And not all utilities have that capability. So this is really helpful to have research institutional support for handling that data, and also interpretation. There was one place where this was really key. We ran into what I would consider a glitch or a discrepancy, where as we went through the chain of models, we were not producing historic hydrology correctly. And as we started talking about it, we really figured out it wasn't the downscaling, the daily downscaling, and it's not the hydrology model, so what was it? And so that's where we figured out it was really in the disaggregation of daily to hourly, and that's another piece that Megan's going to go into more detail with in this next talk. And then to steal something from Megan, it really wasn't a co-production, it's a matter of co-learning, where both sides of the research and the utility work is a joint, reciprocal learning process. Okay? With that, I'm done.